Okay, we're going to talk about our ratio and proportions, all right? So we're going to go through this slideshow and just kind of walk you through it, just talk about it. Ratios and proportions are comparison of two values, okay? They can be expressed in any number of ways. 8 to 12, 8 semicolon 12, or 8 over 12 is a fraction, all express the ratio of 8 to 12. Of course, 8 over 12 is and should be reduced to 2/3, okay? So whenever we have ratios, we need to reduce them. Ratios, as you might well imagine, are going to be used extensively in the geometry. We talked about a rectangle. We're talking about the ratio of length to width or width to length. In this case, the dimensions are given. The width is 12 inches. The length is 32. So the width to length is 12 to 32. 12 over 32, of course, reduces to 3 to 8. That's our ratio, 3 to 8. Okay? In order to properly express ratios, we have to actually be within this using the same units. So you can't make a ratio of 3 to 2 when comparing 3 inches to 2 feet. Okay? We obviously have got to remember that 1 foot is 12 inches, so 2 feet is 24 inches. So the ratio 3 inches to 2 feet is not 3 to 2 by any means. It's 3 to 24 or 1 to 8 in reduced form. Okay? 1 square inch to 1 square foot. Now, recalling a square foot is a square 12 inches on a side, which means that a square foot contains 144 square inches. So 1 square inch to 1 square foot is a 1 to 144 ratio. The ratio of 1 cubic foot to 1 cubic yard, a cubic yard is of course a cube 3 feet on a side. So it's 3 by 3 by 3, length times width times height, which means the volume of that is 27 cubic feet. So 1 cubic foot to 1 cubic yard is a ratio of 1 to 27. Two equal ratios comprise what we call proportion. So we had a 21 to 24 simplifies to 7 to 8. We can set this as an equality, in which case we create a proportion out of it. 21 is to 24, 7 is to 8. Okay, just as it's verbalized right there. All right. A lot of times these are set up in such a way that one of the four values in the proportion is unknown. So we got something like this. 15 is to 10, as 3 is to k, which means that we can set this up as an equation, cross multiply and solve for k. So cross multiplying gives us 15k equals 30, from which of course we get k equals 2. All right. By simplifying the fraction, we could have solved at the same value. Okay, cross multiplying is the tool you're going to use more often than not. Ratios and proportions are seen countless examples. We look at this one. The ratio of men to women at some school is 7 to 9. That's not to say that there are 7 women or 7 men and 9 women. No, okay, there are the ratio of men to women. This is, of course, implying there's more women than men. We are given this information. 1,056 students are at the college. How many are men and how many are women? Okay, we don't know. So we can arbitrarily elect to the men as the value of x. If we let the number of men equaling x, then what is the number of women? What should be the total? 1,056 minus x. So now we set up our proportion. Our proportion would read the men to woman ratio, 7 is to 9, as x is to 1,056 minus x. There it is. There it is set up as a equation. Once it's set up as an equation, we simply will cross multiply. Upon cross multiplying, we can always very easily solve for x. Recalling what is x. X is the number of men. What is the number of women? It is the total number, 1,056, less the number of men, which would give us 594 women. All right. Another example, if 5.5 gallons of gas costs $18.81. How much gas can you purchase for $50? Again, we can say set up a proportion. 5.5 is the 1881 as X is to 50. And we get this as our equation, okay? 5.5 is to 1881 as X is to 50. We cross multiply, and we can solve for X, saying that for $50, we can get 14.6 gallons, all right? Another example, scale maps, okay? 1 inch equals 68 miles. I measure that the distance on the map I have to travel is 7 3/4 inches. What is that actual drive in miles? 1 is to 68 as 7.75 is to X. 1 over 68 equals 7.75X. Cross multiply, X is going to be 775 times 68, or 527 miles, okay? Another example in geometry is a ratio involving 3 terms. So triangle, the angles of a triangle are a ratio of 1 to 2 to 3. Well, that is to imply that you understand that all the angles of a triangle, of course, is equal to 180. So we can easily set this up to say, okay, 1x plus 2x plus 3x equals 180. Solving for x equals 30, which means we're talking about a 30, 60, 90 triangle, okay? We're talking about a 30, 60, 90 triangle. Here are some practice problems for us. We'll have some, additionally, we'll have some practice problems on a worksheet that I will give you as well, okay? There you have it, all right?